So far in class, we have practiced naming ionic and covalent compounds. We've done a little more practice on ionic compounds. They do tend to be a little trickier. We are also going to now start writing down the formulas for ionic compounds. It's going to be a lot easier to do covalent after this, so we're just going to start with this part. So the first thing I need for you to do is I need for you to have your blank notes sheet that has the setup for this information. Read this paragraph here and summarize it in your own words on your sheet. Do not copy it word for word. And then go ahead and copy down these things right here. And then we'll get started on how we actually do this. So go ahead and pause and copy. Okay, so now moving on, let us see what this means when we have our ionic charges. So we actually practiced figuring out where charges are based on where something is on the periodic table. So you're going to need your periodic tables. We should be recognizing a correlation between where an element is on their periodic table and what their ionic charge is. So if I'm looking at anything that is in the first group, group 1A, everything there forms a +1 charge. Everything in group 2A forms a +2 charge. 3A is +3. 4 is plus or minus 4 because they're kind of in the middle as far as when they form electrons to form that stable octet. Here we're going to have -3. These are -2, -1, and 0. We've done that in a previous lesson. So we do need to remember that when we're asked to write formulas. We need to be able to look at a periodic table. Again, see whether something is on the metals or non-metal side, but then also be able to look at the group it's in and figure out what the ionic charge is. Okay, so for the purposes of today's lesson, what you have in your table here already has all of the charges. So what we're really going to be practicing is these sets of steps here to write the formula. So let's look at our first example. Our first example is copper and phosphide. And they give us the charges for both of these, and that's good because our copper ions are actually not in a specific group. They're in the transition metals, which actually means that you can think of it as they transition between a couple of different ionic charges. But again, for today's lesson, they're giving us the charge, so we don't need to worry about that. What we do need to make sure is that you have the symbol and the charge of the ions. If you don't have the charge written down, then you're not going to get the right answer. And there's a whole other things conceptually that are not going to be correct about what you write. So first you write those down. I'm just going to rewrite these up here. I'm going to write copper with that 2+, and then we have the phosphide with the 3-. And sometimes you'll see the negative sign, you'll see the charge in front of the number, sometimes you'll see the number in front. It really doesn't matter for what we're doing. But the next thing it tells you to do is crisscross. The cation charge becomes the anion subscript. So we're going to need to take that number, just the number, not the charge. So we're going to take that 2 and we're going to cross it down to the opposite anion, the anion. And so then that means that we take the phosphide's 3 and that becomes the subscript for the cation. So now we have to clean up the format for our final answer. So when we rewrite this, what we're saying is that we have 3 coppers, and 2 phosphide. This is our final answer. And let's look and see why that is, why that makes this now a neutral compound that does not have ionic charges. We had ionic charges with these things individually. These opposite charges attracted each other. Well, if we had 1 copper with that +2 charge and 1 phosphide with that -3 charge, that does not equal 0. That does not give me a neutral compound. What would happen is I would actually have an extra negative charge left over. Well, we know that negatives are going to attract positives, so it's actually going to attract another positive copper ion. But now when we've done that, we have a +4 positive charge and only -3 here. So that plus 4 is going to keep attracting negatives. So it'll attract another phosphide. If we have our phosphide here, so now again we have a stronger negative pole. We've got more negative ions. So it will attract another positive one. And we come to a point where if we add up our charges here, this is plus 6. If we add these up here, this is negative 6. And this is what's going to make it a neutral compound without charge. So this is the long way of doing it. We are actually truncating it and just doing the Criss-Cross because it's faster, it takes up less space, so it's going to be more helpful to us. If you need to do this as we move along this practice video, go ahead and do that until you get it down where you can just do the Criss-Cross portion. Okay, so now let's do some practice with the problems that you have on the homework. You notice that I did cut out the last 2 columns. I'll show you how to do most of these here, and then you can finish the other 2 on your own. So let's start first of all, let me walk you through how we got the sodium chloride right here. So I have my sodium and I have my chloride. If I put each of these together, they cancel each other out. A plus 1 and a negative 1 will equal 0. This is understood to be a 1. So I only have 1 sodium and 1 chloride. And that's it. That is the formula. Their charges, because they are the same magnitude, just opposite charges, cancel each other out, so it's just 1 of each. When we look at the sodium oxide, that is different. Sodium will always have that plus 1 charge because it's in group 1A. All group 1A atoms become plus 1 charged ions. But here we have the oxide, and oxide has a negative 2 charge. Okay? So if I have a plus 1 minus 2, that does not equal 0. So I cannot put just 1 of each together. I am going to have to use my Criss-Cross method to see how many of each I need. So I take my 1. I'm only going to need 1 oxide, but I'm going to need 2 of the sodiums. And that's where my formula Na2O comes from. And so the way that that makes sense is if we have something that is a plus 1 charge, and let me go ahead and start this one over again. If I have 1 sodium with a plus 1 and an oxide with a negative 2, that does not equal 0. That does not equal 0. I have a negative 2. In order to make it balanced, I would have to have another sodium ion. I need another positive to neutralize that negative 2. So I could add another sodium. And if I add another sodium, well, okay, that there gives me a total positive charge of plus 2. My total negative charge over here is negative 2, so that works. That balances out. Well, since I have 2 sodium atoms here, 2 sodium ions, that's where my subscript of 2 comes in. That's why that's there in the formula. Okay, so that's how the math works. Let's go ahead and move on to potassium. So potassium is in group 1A. It has a plus 1 charge. Chloride is the same anion we're going to be using all the way down. It's in group 7A. 7A, so it gains 1 electron, so it can have its octet. So that's where we get our charges from. Here, this one is 6A. It's 2 away from having an octet, so those 2 electrons that it gains gives it a charge of negative 2. All right, so writing these formulas, this plus here is understood to be a plus 1. So that 1 comes down here. This negative 1, oh look, it's another 1 to 1. 1 there. Our formula is just KCl. That is our balanced formula. So now for the next one, for potassium and oxide, and this would be potassium oxide if we were naming it. This is a plus 1, so we would need 1 oxide. This 2 tells us that we would need 2 of the potassium. So that's K2O. So our formula here would be KCl, and here it would be K2O. Okay, so now for our barium ion. Barium has a +2 charge, so we need 2 chlorides to balance it out. This chloride has an understood charge of -1, so that 1 comes over here. So our formula is just BaCl2. For barium oxide, we already have the same number on both sides. They're already exact opposites, so I can just have one of each together. If you were still going to do the Criss-Cross method, what you would get is Ba2O2. But when we do ionic compounds, we always have to have the lowest whole number ratio of those subscripts. And so because we only needed one of each, our answer is BaO, because we only needed one of each and they canceled each other out. So always look for the lowest whole number ratio of those coefficients. So it's not Ba2O2, it is BaO. Looking at iron 2, the iron 2 charge, and chloride, take that 2, carry it over, cross it over, -1, cross that over. So when we crisscross, we have 1 iron, 2 chloride, iron 2 chloride. Over here, we have a +2 and a -2. Oh, they already cancel each other out, so I know that my formula is just FeO for that one. Chromium 3. So this has a +3 charge, which means we're going to need 3 of the chloride to balance out that +3. We're going to need 3 of this negative ion, and its charge is -1, so we only need to have 1 of the chromium. So this is CrCl3. That's the formula for the chromium +3 charge chloride. Over here, we're going to need 3 of the oxide and 2 of the chromium, which gives us Cr2O3. That is our formula. And if we look at what we have 2 +3s, right? So what's 2 times +3? That's a +6 over here. We have 3 -2s. Okay, so 3 times -2, that's a -6 over here. So yes, mathematically, this crisscross method definitely works. It's a lot faster and a lot easier than just having to do the individual math. So there are those formulas. You might want to, if you haven't been pausing the video, go ahead and pause it and try to do the rest of these 2 columns for a moment, and I will come on back and give you the answers to them, and then you can continue on with the other 2 columns on your own. So here I have set up to do the next 3 cations, lithium, magnesium, and aluminum. Make sure that you are working these out before you look at the answers. Okay, so I've done most of them here. I'm going to do the last one here. 3 carries over, 2 crosses over, Al2O3. There are those answers. Okay, so the next set, the last 3, here they are. Go ahead and pause it and then be ready to pause again to check your answers. Okay, so here are the answers on this side. When we crisscross our charges, this is how we get all of our numbers. So go ahead now and finish the other 2 columns on this assignment, and we'll see you tomorrow.